This next video is a funny one. Well, it's funny to me because I do a lot of math, but for you guys, this is usually something that students feel weird about, a little uncertain, kind of like sticking your hand in like cold jello. It just feels weird. Most people probably don't do that. Anyway, so let's look at example 6.9, and we're going to do this example in two ways. So let's use the quotient rule first. If we use a quotient rule, we say we subtract the exponents because they have the same base. So 3 minus 3 is 0. Whoa! A to the 0th power, that's kind of weird. That's what the quotient rule tells us. So that's the first way of doing it. Let's do it another way. A cubed over a cubed. Let's expand each of these. A cubed is a times a times a. And a cubed is still a times a times a. And I'm going to sneeze. Bless me. You can say bless you, but by the time you see this video, the time for blessings will be long gone. And now we have a fraction with everything multiplied. The factors cancel. And again, when everything cancels, we're left with a 1. So we're really left with 1 over 1, which again is just 1. So we have two ways of simplifying this. One of the ways got us a to the 0, and one of the ways got us 1. So I guess those are the same thing. Right? If two things equal each other, if the same thing equals two things, then by the transitive property, they're equal. All right? And that's our first property, okay? So, the 0 power rule. As long as, there's no craziness happening, a to the 0 is going to be 1. Any positive real number to the power of 0 is 1, okay? For negatives and non-reals and zeros, weird things happen. But as long as a positive number is raised to the 0th exponent, then that's going to be 1. And there's some weird edge cases that we won't really talk about in this class. Let's do example 610. So simplify this. 5x cubed yz to the 5th raised to the 0th power. Oh, I did it. That's why they gave me a master's degree in math. Look how fast I did that problem. We just said any positive real number raised to the 0th power is 1. I don't know what number this inside is. But as long as it's not anything super weird, it'll be 1. You could do this out longer using other properties, right? You could say this is 5 to the 0th times x cubed to the 0th times y to the 0th times z to the 5th to the 0th power. And then each one of these is going to be 1 as well. But you can also just jump straight to this final answer. Okay? So watch out for that. Part B is similar, but a little more complicated. We have two things multiplied by each other. And you can do this in either order. Maybe you want to multiply these together and add the exponents. X squared times x to the 0th. Add those exponents. 2 plus 0 is just x squared, 2, for your exponent. Or you could deal with the zeros first. It's up to you. I like dealing with the zeros first. I like saying y to the 0th. Why even write that? This is the same thing as 3x squared times 5y to the 4th. Because x to the 0th is 1, so multiplying by 1 doesn't change this. Scooch. Thank you, paper. And now we multiply the numbers together. 3 times 5 is 15. Multiply the variables together. X squared and y to the 4th, they don't combine at all. And again, sometimes I underline things to show when I've dealt with them. And that's a way of getting to our answer here. So next up, we're going to introduce another fun little mathematical algebraic rule using the same idea as before. Let's look at a cubed and a to the 5th in two ways. So one way of looking at this is with the quotient rule again. 3 minus 5 is negative 2. Yes, we're going to talk about negative exponents. And these are the ones that usually trip people up. So watch out. Be on the lookout. Another way you can do this problem, though, is saying, well, a cubed is 3a's multiplied by each other. A to the 5th is 5a's multiplied by each other. And if everything's factored out like this, we can cancel. And when we cancel, what's left on the top? Not a 0. When things cancel, remember, they cancel to 1. So this equals 1 over a times a, 1 over a squared. So just like we did at the beginning of the video, we'll say, well, if this equals that, and this equals that, I guess they're the same thing. We'll say a to the negative second just means 1 over a squared. So in general, negative exponents move something from the numerator to the denominator, or vice versa. Let's get that official property. We got 3 parts of this property. This one is the one we just did. A negative exponent moves it to the denominator. If there's a negative exponent already in the denominator, it moves it to the numerator. And notice that there's no denominator here of 1, but we could think about a denominator of 1. Now we can kind of combine these to say that if we have a fraction with a negative exponent, well, the numerator goes to the denominator, and the denominator goes to the numerator. Or it just flips it upside down. Negative exponents flip things upside down. And we got another skull and crossbones here. The pirate's life for me. It be important to note the negative exponent. I have no pirate accent. Does not imply the expression is negative, only the reciprocal. We're not turning anything negative here, even though the exponent is negative. Just reciprocating things, okay? That'll be the next activity. We'll reciprocate by making you guys do a pirate accent. That's a mature way of dealing with emotional instability, right? Is force you guys to do it as well. All right. So we mentioned at the beginning of this module what it means for something to simplify. And that's why we're specifying that when we simplify, all exponents have to be positive, because this is not simplified. This is simplified, okay? That's what that was talking about. So let's do one last example before the next video, and the next video is really gonna take the cake. You guys are gonna like the next video. And I say that full of sarcasm. It's not so bad though. We'll go through it together. All right. Example 612. Simplify all this stuff. M n to the 5th divided by m to the 4th n cubed over with an exponent of negative 2. So we're going to use that property that we just used. A negative exponent means reciprocal. So let's reciprocate this whole fraction. The exponent is going to become positive. We're using up the negative exponent right here by reciprocating all this stuff. This numerator becomes the denominator. This denominator becomes the numerator. Switch places. And now we'll continue simplifying using the stuff from the previous video. Couple of orders. We can start with the inside. We could start with the outside. It's up to you. I'll start with the inside this time. Let's get some variety, but both should get the same answer. Quotient rule. M to the 4th. This is m to the 1st, remember? 4 minus 1 is m cubed. 3 minus 5 is negative 2. Well, we used up everything in the denominator, so we don't have to write a denominator. But we don't want negative exponents. We have n to the negative 2nd. Remember that negative moves it to the denominator. So this is really what that n is doing. Okay. This is sometimes an optional step that I skip. But this is really what's happening. And now this whole thing is getting squared. So the top is getting squared. Multiply those exponents, m to the 6th. The bottom is getting squared. Multiply those exponents as well. N to the 4th. And we have our final answer. Let's do 2 more here. 7x to the negative 5th over 3 to the negative 1y, 7. That's not a 7, that's a z, Jason. To the negative 4th. Negative exponents everywhere. So that's what we're going to do first. Be very careful, though. The 7, right, this is 7 times x to the negative 5th. The 7 doesn't have the negative exponent here. The 7's all alone. So 7, nothing happens with the 7. Let's deal with this negative exponent, this x to the negative 5th. Negative exponent makes go on a journey to the denominator. And the negative gets used up in that journey, like gasoline. 3 to the negative 1, that negative exponent makes it to the numerator. The negatives make the thing reciprocate, go to the other side of the fraction bar. The negative gets used up. We're left with 3 to the positive 1. Y? Y doesn't have any exponent. Y is just going to chill. Because it's y times z to the negative 4th. And again, the negative makes it go on a journey up to the top. And the negative gets used up. Negative exponents are now gone, and we can simplify. Okay, so 7 times 3 is 21. Z to the 4th, and on the bottom we're left with x to the 5th times y. The second one, that was the second one. The last one in this video is C. This is a nice chill one. 2 divided by 5, a to the negative 4th. There's only one thing to do here. Let's use that negative exponent. Again, the 5 is not part of it. The 5 has its own exponent of 1. But the a has the negative exponent, so the a is coming up to the top. And the exponent's becoming positive. So it's only one thing is happening here. There's one negative exponent. We use the negative exponent to get it to the top. There. That's a non-sarcastic eyebrowed smiley face. Celebrating the end of the video. It doesn't have a head though. I'm sorry. Good luck.